Good morning, students. My name is Anjanam Naidu, your chemistry teacher. Sir, today discuss about very important topic in first year chemistry, physical chemistry, that is a chemical equilibrium. Name of the lesson is Sir, start the before lesson. What is the chemical equation or chemical reaction? Students, generally, if any chemical reactions, a reactant is converted to the product. That is right or wrong? In this, every chemical reaction having reactant and product. Reactants start the chemical reaction, and product is the formation of product in a chemical reaction. Means that is the completion of the reaction, that is to indicate the product. Right or wrong? Okay. In this chemical reaction, generally two types. One is the irreversible reaction, another one is the reversible reaction. Students, first one is the talk about irreversible reactions. Already you know that in irreversible reaction, reactants convert to the product, and products does not convert to the reactant of chemical reaction. Means those chemical reactions only single direction proceed. That all type of chemical reactions is called irreversible reactions. I given one definition of irreversible reaction. In these reactions, the reactants completely convert into product. Like 100% of reaction takes place. Only one direction is a proceed. Students, clear my point or not? In the one of the examples of irreversible reactions is the CDPN, like combustion reactions. Second one is the decomposition reactions. Third one is the precipitate reactions. And fourth one is the neutralization reactions. Students, in the first one is the combustion reactions, like a combination of two or more than two elements to form a product. Like have example, that is the magnesium ribbon is react with oxygen to form magnesium oxide. Again, the magnesium oxide does not convert to the magnesium and oxygen. That is the only one direction proceed. Like only magnesium is react with oxygen to form magnesium oxide. That is the combustion, means that is the magnesium and oxygen, that is the both two elements will be combined to form one of the product. That is the combustion reaction. Okay, and the second one is the students, that is the 2016 JEE mains question. In this ammonium nitrite, like NH4NO2, and ammonium nitrate is the NH4NO3, both are two most important. in the ammonium nitrite like NS4NO2 is decomposed to N2 plus 2H2O. For suppose you have taken ammonium nitrate like NS4NO3 is taken or applied to heat to form nitrous oxide, that is a laughing gas, N2O plus 2H2O water molecule is getting. That is the two decomposition reaction is the most important for the JEE mains. And already there is the previous question 2016. Ammonium nitrite, NS4NO2 is a nitrite, is decomposed to nitrogen gas like N2 plus 2H2O. If for suppose ammonium nitrate, students, ammonium nitrate is the NS4NO3, that is the nitrate. Ammonium nitrate decomposed to N2 like nitrous gas, that is called for laughing gas. Nitrous gas plus 2 water molecule, that means 2 moles of water molecule. Is clear my point or not? Okay, one more decomposition reaction, students. In this calcium carbonate, when applied to heat, calcium oxide and CO2 gas. Student, that is the most important in the decomposition of calcium carbonate. Have taken open vessel. Like open vessel have taken, only gas will be escaped outside. So that example is belongs to the irreversible reaction. Students, most important, calcium carbonate. In this calcium carbonate, after decomposition in open vessel, I have taken open vessel, I have must belongs to the irreversible reaction. Why? Because also one of the CO2 gas came outside. That is I have taken calcium carbonate in the open vessel is have example to the irreversible reaction. For suppose in the calcium carbonate I have taken closed vessel, what will do? That is the example is the reversible reaction. Okay, in the closed container, in the calcium carbonate taken in the closed container, that is the example to the reversible reaction. Why? Because also I have taken closed container and gas will be again return to the formation of reactant. That is the forward reaction and backward reaction takes place. Then the gas, in the formation of gas does not escape outside in the closed vessel. Mind it point. Clear my point or not, students? Okay, one more. Students, clear my point or not? In the calcium carbonate have taken decomposition of calcium carbonate in a open vessel is example to the irreversible reaction, because in the CO2 gas will be came outside. Like in the closed vessel, that CO2 gas does not outside in the container. Why? Because also taken closed vessel and gas will be come to formation of reactant. Okay, in the calcium carbonate taken closed vessel, that is the example of what is the example? Reversible reaction. Okay, sir, students, next one is the like neutralization reaction. Neutralization reaction means you have already learned in previous class. That is the neutralization means it is salt formation. Means you have when the reaction of acid and base to form salt and water molecule. Students, all neutralization reactions to example to the irreversible reactions. Why? Because also and the salt when applied to the water molecule does not give to the acid and base. That is the no reaction, students. So only when acid, HCl is the act as acid and NaOH means sodium hydroxide is the base. Both will be reactive to form salt and water molecule. That is the neutralization reaction. That reaction is called for neutralization reaction. All neutralization reactions is example to the irreversible reaction, no doubt at all, students. Okay, one more example in the precipitate reactions. Students, in the precipitate reaction means one type of precipitate. That precipitate does not dissolve in the solvent. The precipitate is settle of the bottom of the container, bottom of the flask. Have taken NaCl, that is the sodium chloride, is react with silver nitrate. AgNO3 act as a silver nitrate, both to Na plus Cl minus, that is the cleaved Na plus Cl minus and AgNO3 Ag plus NO3 minus. One positive terminal of the one compound is react with another negative terminal of the another compound. Like Na plus is react with Cl, Ag plus is react with Cl minus, that is the AgCl, that is the one type of precipitate. In the precipitate you have direction down the arrow direction. Why? Because also that precipitate does not dissolve in the any solvent, like water. Like any solvent means you have taken water. That's that precipitate is the only settle or bottom of the container, AgCl, that is they have used to the arrow mark in the downward direction, and remaining compound is the NaNO3. Students, in the precipitate means you have only AgCl act as a white precipitate. Students, clear my point or not? That is the CDPN is examples of irreversible reaction. Students, clear my point or not? Okay. Next one is the reversible reactions. Students, in the reversible reactions, reactants is convert to the product and product again convert to the reactant. That is the only 50% of reaction is proceed. Okay, students, like in the reversible reactions having only one is the forward reaction, that is the reactant is convert to the product, and again product is convert to the reactant, that is the backward reaction. Means those chemical reactions having proceed to the either sides, like rate of means that is the forward reaction and that is the backward reaction. Means reactant is convert to the product, that is the forward reaction, and again product is convert to the reactant is called backward reaction. In both forward and backward reaction present in the chemical reaction, this type of chemical reaction is called reversible reactions. Students, in the reversible reaction I give an example, I give a definition is what is the definition? In these reactions the reactants are not completely converted into product, like not 100% chemical reaction takes place. Only that is the only 50% reaction is proceed, that is the only reactant is converted to the product and product is converted to the reactant. Half of the reaction is takes place. Okay, students, in the reversible reaction is example to the H2 plus Ci2 is give rise to 2HI and 2HI is converted to the H2 plus Ci2. In the reaction observed, H2 plus Ci2 is converted to the 2HI, that is the forward reaction, and one more student, that is the forward reaction, and again that is the backward reaction. Means 2HI is converted to the H2 plus Ci2, that is the backward reaction. Means those chemical reactions having forward reaction and backward reaction. The type of chemical reactions is called reversible reactions. And one more point, students, that is the most example have taken calcium carbonate, decomposition of calcium carbonate, have getting calcium oxide and CO2 gas, that is the taken in the closed vessel. In the closed vessel, that is the example of closed vessel of the calcium carbonate is example to the reversible reaction. In the case of have taken open vessel, calcium carbonate, decomposition of calcium carbonate, you have taken open vessel, that is the irreversible reaction. Decomposition of calcium carbonate in closed vessel, that is example to the reversible reaction. Students, why are taken in the closed vessel, that is example to the reversible reaction. Students, one more point, in the CO2 gas is the formed, and the CO2 gas is the only present in the closed container or closed vessel. Again CO2 gas will be cannot outside of the gun, means does not escape outside in the CO2 gas. Only CO2 gas present in the closed container. Again CO2 gas will be returned to the reactant is formation. So that causes to the this help of to form a formation of reactant, like CaCO3 is decomposition of CaCO3, CaO plus CO2, and both are will be combined to form CaCO3 in a closed vessel or closed container. That example to the reversible reaction. Okay, clear my point or not? Okay, one more. Students, rate. What is the meaning of rate? Like in the term rate means change in concentration. I have taken reactant or product that is having concentration. Student, that is the change in concentration per time interval. That is the definition of rate, where rate is equal to change in concentration by time. Students, already know that units of concentration mole per liter in learn about the mole concept or stoichiometry. Okay, in the concentration is nothing but mole per liter, in the time is a second minute used that. Okay, in the mole per liter into second inverse, that is the overall units of rate. Rate means only change in concentration by time interval. Okay, only just that is a decrease the concentration or increase the concentration, whatever it may be used, that only per time intervals or time period, that is a certain particular time period you have taken the change in concentration of the reactant or product. Okay, students, in the definition of rate based on the reactants. Students, one more point, in the if any chemical reactions reactant is converted to the product, already you know that in the reactants always decrease to form product. Okay, means if any chemical reaction reactions reactants is converted to the product, means reactants always decrease to form a product always increase, but in the term only concentration of the reactant is decreases. How much amount of concentration will be decreased of the left side, means reactant side, same amount of concentration will be increased of the product side. Students, clear my point or not? Okay, in the term based on the reactant is the definition of rate, decrease the concentration of reactant by time interval. Students, clear my point or not? Decrease the concentration of reactant by time interval, that is the definition of rate. Okay, based on the product, students, increase the concentration of reactant by time interval, whatever it may be, have used to the any definition based on the reactant or based on the product. I repeat once again, students, based on the reactant, what is the definition of rate? Decrease the concentration of reactant by time interval, that is the definition of rate. Okay, one more definition is based on the product. Increase the concentration of product by time interval. Okay, in a chemical reaction, one is the decrease the concentration of, another one is the increase the concentration of the product. Okay. Students, chemical equilibrium. Okay, in the definition of chemical equilibrium. Okay, students, in the chemical equilibrium means only if any chemical reaction, that is the equal change in concentration of reactants and product. Okay, in the definition of chemical equilibrium, one more definition. They given one definition: the state which rate of forward reaction is equal to the rate of backward reaction is called chemical equilibrium. In overall, the rate of students, the rate of forward reaction equal to rate of backward reaction. If only reversible reaction only, in the reversible reaction is taken only closed vessel. Students, in the chemical equilibrium applied to the either side of the reaction, means that is the either side means that is applied to the forward reaction, that is the backward reaction. At the time of equilibrium position does not change the concentration, means how decrease the concentration or increase the concentration does not affect the any change of the observed. Means student, that is the rate of forward reaction equal to rate of backward reaction. Student, clear my point or not? In the chemical equilibrium means the states of rate of forward reaction equal to rate of backward reaction. That means does not change the concentration of reactant or product at the time of equilibrium position only. Students, in the equilibrium state does not change any concentration of reactant or product. That state is called chemical equilibrium. In overall definition of chemical equilibrium, the rate of forward reaction equal to rate of backward reaction. Students, clear my point or not? Okay, next one. Students, in the graphical representation is the most important. In the graph is taken, rate is taken on the y-axis and time is taken on the x-axis. Students, one more point, that is a like reactant curve, that is a product curve. In the first graph is observed, that is a concentration of reactant decrease and concentration of product is the increased, and certain place, that is the point is the end point, that is the equilibrium state. At the time of equilibrium state, students, the rate of forward reaction equal to rate of backward reaction is observed. Means that point does not change the concentration of reactant and product. That particular area, in this area is called equilibrium state. Students, clear my point or not? Okay, students, one more graph is observed. I have taken concentration and time. Concentration is nothing but a rate. Students, in the that is the curve is the reactant curve, that is the change in concentration decrease and increase the concentration of product. Students, one more point, in the equilibrium position only concentration of reactant is greater than compared to the concentration of product. In the reactant does not involve the does not mix it to the does not involve or does not mix it to the product concentration. Only in the reactant concentration present in the above the plane. In the in concentration of product curve is the only below the plane, does not mix it. So in this graph observed, only concentration of reactant is greater than concentration of product, that is graph will be observed at the time of equilibrium state. Okay, one more, after equilibrium state, one more taken, concentration is taken in the y-axis and time is taken in the x-axis. Students, in the concentration of reactant will be decreased and concentration of product will be increased. After equilibrium reached and cross the equilibrium, in the concentration of product is more than compared to the concentration of the reactant. That both two graphs will be observed. So That is the concentration of the reactant curve, sir. That is the concentration of product. In the after cross the equilibrium state, in the concentration of product will be high than compared to the concentration of the reactant. Both two curves observed, only concentration of product will be always greater than compared to the concentration of reactant. Clear my point, sir?